Hello students, and welcome back to our weekly lecture. The topic and theme for this week is ethics, and we are going to talk about not just personal ethics but academic ethics as well as professional/engineering ethics. One of the first things I'd like to kind of discuss with you all is the fact that the words and the phrases ethics and morality, morals, are often used synonymously, and the truth is that they are different. Your morals are your personal values, that which is created over time and through your experiences. And ethics is actually the study of how people utilize their morals when they're making decisions in their personal life, in their academic life, and in their professional life as well. And so ethical behavior it's defined as honesty and fairness and equity in all of the relationships that you have, whether they again be personal or they be professional. So that's why today we're going to take time and talk about personal ethics, academic ethics, and professional engineering ethics. So with regard to personal ethics, they basically refer to an individual's moral principles, their beliefs, and their values. And all of those guide the decisions that we make on a daily basis, because we make decisions every single day, whether it relates to your family life, your personal life, your finances, your relationships. We're always making decisions, and those decisions are based on your morals and your values. For example, if you are someone who takes responsibility for everything that you do, then it's safe to say that responsibility is one of your values. It's something that you take pride in, and it becomes part of you. It is one of your moral values. And our moral values, they are instilled in us through everything that we experience. How you were raised, your upbringing has molded you and shaped you. Your cultural background, where you're from in this great, big, beautiful world, impacts who you are, and it impacts the values that you have. So all of those personal experiences create who we are, and they create our personal value system. And then finally, your philosophical take on things in life, your religious beliefs, again, all of those make you who you are and create your personal value system. It's very likely that your personal values will impact how you perform, what you do in the workplace. And again, because we said everyone is so different, right? Everyone has such a different background. For that reason, there have to be standards. There have to be standards in academics, for example. You're all in college now. And there have to be standards in industry and in the workplace. And that's what we're going to talk about today. It's important, again, to follow those academic standards. And we are going to head now over to the Office of Academic Integrity, where we're going to delve a little deeper into UCF standards that have been set up for you. Hello again. I am here in the Farrell Commons area, and I'm outside the Office of Student Conduct and Academic Integrity. Basically, what we want all of you to know is that regardless of where you went to high school, what state you're from, what country you're from, you're all here at UCF now. And as a result, everybody has to abide by the same academic standards that the university has set for academic integrity and for student conduct as well. And it's important that these standards exist, because your degree needs to maintain its value, right? And if everyone knows that you've come from an incredible institution that has extremely high standards for academics and student conduct, well, that's a good thing, and we want to make sure that is maintained. So basically, I know it can get a little confusing sometimes, so I'm just going to keep it very simple. No cheating, all right, on exams, on any kind of assignment, and no plagiarism. You are not to turn in something that you did not do yourself. I can't lie, I have had to turn students into that integrity board that you read about in your module this week. It was not fun for me. It was very disheartening. And it was obvious. It was a CAD assignment, and you know, when submissions are made and 8 different students had the exact same font in the exact same size in the exact same color, and the photos were the exact same down to the tiniest detail, it became obvious to the TAs, and they brought that to me, and I had to bring it to Dr. Chopra, who is in charge of academic affairs, and he'll be chatting with you in just a minute. But the bottom line is that all of those students had to go before the Academic Integrity Board. That's not something you want to have to do, all right? So that's why we're talking about it now. So again, we here at UCF, we have this creed, and we want you to focus and abide by everything there. Excellence, creativity, community, scholarship, all important tenets of what we are at UCF. But that one there at the top is the most important, in all honesty. Integrity. Academic integrity is critical. It is crucial. We have a book called The Golden Rule. It is the student handbook for conduct and for academic integrity. It's online. I can't give you a copy of it, and it's kind of long. It's pages and dozens and dozens of pages long. But just know that it does outline all of our standards. And if you ever question anything, you can always refer back to our student handbook. The bottom line with integrity is that if you cheat, you really are just cheating yourself. Don't care what you did in high school, but just know that here, everything you're doing in your academics, everything you're learning, it's all building on top of each other. And if you cheat yourself in one class and it's the building block for the next class, you're not going to do well, all right? You're not going to become the engineer I think that all of you want to become. So again, cheating is cheating yourself. You've heard it before, and you need to live by that, all right? To wrap things up and let you know again just how important integrity is here at the University of Central Florida, I'd like to reintroduce to you our Associate Dean for undergraduate students, and that is Dr. Manoj Chopra.
Hi, everyone. It's good to be back with you again. So I hope the semester is going well. Over your next few years, I'd love to meet all of you. I'm in the atrium all the time. If you see me, come by, say hi. I'd like to meet you in good circumstances, like looking at your designs or talking about your courses, but probably not in a circumstance where you are in front of me for an academic integrity issue. And so I want to talk a little bit about integrity, both academics, and then your integrity here in school will translate to your professional integrity and how you do your job. So while you're here, just pay attention to the ethics lecture today and what Ms. Sullivan's telling you about how to do your work independently, how to rely on good sources, work together if you have to, if you're allowed to, but try to have high level of integrity and professionalism. This is something that we don't give you a course, but we teach you how to become ethical as you move forward. Ethics is the most important thing for an engineer or a computer scientist. And I can tell you that because the impact of being unethical can have a major impact, often loss of life in some cases. So let me just take a few minutes in 2018, a few things that happened in the nation that caught my attention, and I wrote an editorial for the newspaper. And I called it The Engineering Profession. Remember, when I say engineering, computer science is also a part of that. The engineering profession must reestablish its relationship of trust following these catastrophes. And I won't read the whole article, you can Google it, but I can just say a few things here. The past month has been very disheartening for me as an engineer. A confluence of national events of catastrophic failure and stories of inadequate design decisions have shined a negative light on our profession. I'm paraphrasing. But this is the word I use over and over again in this article. This should never happen. And let me say that again. The things that you're doing now, if you're unethical or unprofessional, those are bad things that will happen both to your community, your engineering community, your profession, and that should never happen. Under no circumstances should we do things that cause a loss of life. And you are all engineers, that potentially will be in that position. So I'm asking myself, what has happened to the bedrock principles of engineering design? And then what had happened at that time in 2018 were two things. They continue to happen. One was the Florida International University Miami bridge disaster, and that was caused by unethical things or design failures. A blowout of a jet engine, Southwest then. Boeing hasn't done better since then. And so this is just things that result in loss of life. And so please be professional in your work. Please be ethical. Please don't plagiarize. Please have high level of conduct, because again, I want to see you, but not in an academic conduct case. Thank you. I never actually told you how ethics manifest themselves into your actions, and that's by good decision making. So remember, when you are faced with a difficult decision, don't take the easy way out, take the ethical way out. And also, when no one's looking, if you make the right decision, that's the right idea. That's the professionalism that we're seeking. So we want the employers, the entire community to think that UCF students, particularly engineers and computer scientists, have high level of ethics and professionalism. Bye.
Part of academic ethics also includes research ethics. And today, you're going to hear from a doctoral student who is currently doing research, but he also did undergraduate research, and many of you hopefully will be doing that as well. So please pay attention and learn from one of our former graduate teaching assistants for this 1006 class, Mr. Maxwell Booth.
Hello, my name is Maxwell Booth. I am an aerospace PhD student here at the University of Central Florida. Previously, I was the GTA for the freshman intro class for about 2.5 years. Currently, I'm a PhD candidate and a graduate research assistant here at the University of Central Florida under Dr. Jeffrey Kaufman and the Structural Dynamics and Adaptive Structures Lab. So what we do there is kind of two main things. We work with adaptive structures, which morphing airfoils. My specific research is in morphing composites due to temperature. And then another thing we work there is structural dynamics, vibrations, moving beams, piezoelectric materials, all those kind of fun things.
I asked you here today because you were an undergraduate researcher, and now you've moved into this realm of doing graduate and PhD level doctoral work. What advice would you give our freshman students? Because many of the people in our audience right now, they will be doing undergraduate research. And with regard to research integrity and ethics in engineering, what advice would you give to them?
Yeah, I kind of take it as a two-step approach. First step comes from your advisor. So my advisor, Dr. Kaufman, he made it very clear from day one, the results are the results. If it angers maybe someone we're working with, or it doesn't align with what you originally thought, that does not matter. We just like to show the results and then learn from them. Even if they don't line up, you can still learn from something that you maybe failed at. And number two is more of a personal approach. I enjoy the work that I do, and so I take pride in the work that I do. And so lying about, say, a result just to build some sort of notion that I might have had before is not something that I could do willingly. Like my brain won't let me do that. It's definitely a pride thing, and knowing that the information that you're providing out there with your research can be used for further generations, and you want them to trust the research that came before, and that's definitely a big thing. And I think finally something that really stuck with me as far as undergrad goes is I think heat transfer, which is a class you guys haven't gotten to yet. My professor kind of drove home the fact that you are engineers at the end of the day, and depending on where you go to work, you might hurt someone if you lie. You might hurt someone if you mess up, but you have to own up to that. Tell your boss. Ethics is a big part in research in the private industry, the public industry, everywhere. So it's definitely something that is really important.
So basically, integrity and developing and maintaining your integrity, it starts here, right?
Yeah. It starts in the beginning. It starts in the classroom more than anything, I think. You should not cheat on tests. You should do your own homework. I'm laughing because that sounds kind of simple, But it then starts when you move on to research or once you get an internship or something like that. But I think the first thing that I mentioned from your boss is definitely a big thing. It's nice to know that there's no pressure on the results, no matter who or what we're giving the results to. Always just give the results, because at the end of the day, that's all they want to see. They want to see what you got, not what they want to hear. All right, one more message, quick shameless plug. If you are in aerospace or mechanical and you're interested in undergraduate research in adaptive structures or structural dynamics, please feel free to Google that before. But email my advisor, Dr. Jeffrey Kaufman. You can find his email on the MAE faculty website. You can just Google that too.
Hello again, students. I'm excited to have the opportunity to introduce you to the co-founder of UCF's Center for Ethics. I have with me Dr. Stephen Kubler, who is a professor of chemistry and optics. We all learned about optics and photonics last week, and he is one of the instructors within that college, and again, also the founder of our Center for Ethics, which I want to make you aware of, the fact that it exists, and let you just know that you can reach out to Dr. Kubler if you have questions regarding engineering ethics or you want to get involved in the Center for Ethics. So with that being said, thank you so much. We appreciate you joining us.
Thanks
and
so much.
Please meet our engineering freshmen.
Yeah, hello everyone. Thanks very much for listening. I hope you learned something from this. And just real quick, I really admire what engineers do. I'm more in the physical sciences. Optics lets me play in engineering, but it's a remarkable career path you're on, and you're at a great place to do that here at UCF.
Dr. Kubler, why do we have a Center for Ethics at UCF?
So the Center for Ethics is really a place, an opportunity for UCF to make real inroads into how we educate students and to be ahead of the curve in many ways relative to other STEM programs across the country. Increasingly, people have recognized that it's not enough to just learn the equations. I think engineers in your community will know that, sure, you also have to think about design and maybe sustainability and customer relations and such. Ethics is a part of that because there are ways to do design and implementation correctly and ways to do it incorrectly. And I think on the forefront of everyone's mind might be things like cutting corners and using improper materials, but it's much more subtle than that. There's often these value trade-offs that we have to consider in all of our work, engineering especially. And the value trade-offs might be akin to what you think of as an engineer when you have to optimize function, right? So I can say I'd like the best car, and the best car might for some mean the greatest acceleration and the greatest fuel efficiency. Well, those are mutually exclusive, right? I can have a Lamborghini or a Prius and they ain't the same thing. Often we have to optimize one against the other. We're making a trade-off. And even in ethics, and there are trade-offs to be made. When you make a choice, there are certain values you consider. So back to engineering, if a customer comes and says, I want to design this for the cheapest cost, your firm may say, yeah, but safety is really important to us. You personally may say design and function is important, and the profession of engineers, whatever your subdiscipline is, might say, oh yeah, but so is sustainability. How do you marry all of those constraints? How do you weigh those values? Ethics is really about thinking about frameworks to do that well, and that's got to be a big part of engineering in all disciplines. The Center for Ethics is looking at how do we teach that? How do students learn that practice? How do we navigate our own personal values to the values of our profession? And we're actually doing NSF-funded research to study that, but in parallel, we're trying to provide content workshops and other things that help bring not just students, but also faculty and administrators up that ethics learning curve so that we create a culture at UCF that's really focused on ethics as a foundation for being good professionals.
Oh, awesome. And then finally, can you tell us quickly about the Ethically Speaking series that you host?
Yeah, Ethically Speaking is just another of the programming units that we have to support our broader mission in the Ethics Center. So each semester we bring in 2 or 3 speakers who are experts in some area, some topic, generally something that's really on the forefront of people's minds. So just yesterday we had an event that looked at emotion in engineering? How do individuals' emotions steer or change the way they think about design? That was a fascinating discussion and maybe a little bit more abstracted, but obviously something that's very important because our emotional response to things connects directly to our values and what we think is important. Whether we think about the product has to be the safest or the product also has to be the cheapest and how we'll weigh that, that's going to be maybe driven by our own emotions and response to those values. We've also had, in a totally different area, talks on artificial life. Literally, a biomedical engineer joined us who has spearheaded the design and genetic or engineering of organisms to create what he calls xenobots, basically a reproducing species that was not known on Earth before his work. And note I say reproducing, which means the genetic modification allows this thing in such a way that it can reproduce itself with phenotypes and structure that was unknown beforehand. And these things have arguably robotic functions. You can think about maybe through this kind of innovation moving toward nanobots, things that can be put in vivo to rout out cancer cells or do other things. Really fascinating ethical questions though, right? Creating artificial life, what does that mean? We've done a lot of work with AI. In the more science fiction realm, we can ask questions in ethically speaking. What does it mean when you create a sentient being? If we can actually get there with AI, should we, could we? Or if we could, should we? But even before we get there, how much does AI enter into our lives? Are we cognizant of it? Do we have to give approval for that? What about the intellectual property associated with it? Many questions you've probably heard before. Ethically Speaking provides a forum for discussing those things and involving students in that conversation, as well as outside speakers who are expert or other faculty or whatever. So it really is a very inclusive place where everyone's ideas can come out in discussion.
Oh, that's awesome. And I will be sure to let the freshmen know every time you're hosting an ethically speaking event.
I hope we'll see them there for sure. We also, I would mention, have the Be Better Club. And the Center for Ethics was actually co-founded not just by me, but by Dr. Jonathan Beaver, my collaborator who is a philosopher, and he leads the Be Better Club. And the Be Better Club is much more informal, where instead of having an outside speaker, we often first listen to a podcast on a theme and then come together and discuss it. So those are two programming areas that you can find out about just by visiting Center for Ethics at UCF.
All right, excellent. Thank you so much for sharing this information with the freshmen. You take care.
Thank you. I hope you guys check in. Shoot me, this is a broad invitation, shoot me an email if you have any questions. I hope to see you and good luck with your work in engineering.
All right, here's where we want to take some moments and talk about professional ethics. Basically, your professional ethics are the standards and the moral conduct that is expected of an engineer within the profession of engineering. It applies to the profession itself in general, as well as to the individual practitioners, because we are all so different and we have different opinions about things. Professional ethics had to be established because you have to take all of the different people working on a project and know that they're all going to abide by common standards. And those standards were established by many of the professional societies that you've heard about. ASCE, civil engineers, ASME, the mechanical engineers, IEEE, the electrical engineers. So they've set the standards within the engineering professions to maintain that continuity and basically maintain the fact that we all know what's produced by engineers is top quality and will keep us safe. Engineering ethics, as a reminder, again, it's the study of the moral issues and decisions that are made by people practicing in the field of engineering. And what are some of the issues that you may face as an engineer that may cause you to kind of sit back and say, I really need to think about this. This is not something I know is yes or no immediately. In life, as you well know, living from day to day and making decisions about different things every day, there's gray area. Areas that can come up include, for example, conflicts of interest, threats to the safety of people or the environment, discussions of trade secrets or proprietary information. Do you or do you not accept a gift or something from a contractor you're working with, or a politician who's hoping to get a particular job completed in a certain manner? The honesty in research we've talked about. You simply report what the data is. You are not to put your opinion, you are not to tweak it or change it. You simply report the data. That builds confidence among the public. And then finally, there's problems inevitably that will result from new and revolutionary technologies. Many years ago, when the calculator came into, into being a common tool, people were fearful that engineers wouldn't really know anything. The calculator would do everything. Well, we know that didn't happen. Today's potentially new revolutionary technology on the tip of everyone's tongue is the two letters AI, right? And what is AI going to do to our profession and to the world in general? That's a technology that everyone is very uncertain about right now. But one thing that has never changed is the expectations of an engineer. First and foremost, you have to be technically competent. If you recall a lecture just a few weeks ago, Dr. Tim Kotner really hit upon the fact that now, as a student, it's your time to learn the basics so you can become technically competent in your area as you grow as an engineer. You're not going to know everything as an intern, by the way. I know everyone's like, oh, I want an internship. Well, when you get it, you're going to be like, what do I do? What do I do? Employers know you're not going to need to know everything, but they do want to know that you have certain technical competencies that you've learned in school. This technical competency, it's also very, very important that it's based on strong academic integrity, right? Don't cheat your way through school. It's not going to make you a technically competent engineer. Trust me on that. The way you practice is the way you're going to play, right? And if you cheat through school, does that mean you're going to cheat as a professional? I don't know. I hope not. But the standard is there. There's a study that came out recently about nurses. Hate to pick on them, but they're the ones the study was done on. And there was a strong percentage of academic dishonesty. And sadly, in this qualitative research, they found that it did translate into their next word on my list here, into their professionalism. And that's not good. That's not good. That's not good for the health and the safety of people who are, being treated by those nurses, for example. But again, technical competency, extremely important. And then professionalism. Professionalism is simply, just taking your job seriously, doing what you're asked to do, completing tasks, respecting one another. And again, just doing good work. When you're at work, you have, you are businesslike. You're not too casual where you make people uncomfortable. It is a place of business and you have to maintain standards. Speaking of standards, maintaining high ethical standards is obviously something that's very, very important and is a high expectation for an engineer. If you make a mistake, you need to admit it. If you know something is being done incorrectly and you don't expose it, that's a bad thing. One of the things that they expect is that you admit mistakes, errors, and you have the ability to speak up and the courage to speak up when that becomes necessary as part of a project. So the engineer has to deal with a lot of different groups. Sometimes I joke and say I have so many different bosses here around UCF, and it's true because there's a hierarchy, right, in a bureaucracy like a big university. But the engineer also has to deal with a lot of different groups. As an example, society, right? What you do as an engineer impacts society in one way or another. So when you have all of these entities that you are beholden to and have to work with, the question is when the duties conflict, when these parties tend to conflict with each other, which group should take precedence? Meaning, if the client wants something done and the employer says, well, we're out of budget, so we're not going to do it. Well, that's a conflict right there. But in all this different play out here, who is the ultimate top priority as an engineer? And the answer to that is society. Society, the public, people in the public, in society, they are always number one. Number one. It's always about the public's health and safety. So, different groups you work with can argue all they want, but the bottom line is the top priority for an engineer forever and always is the public health and safety. So as a quick example, in the 3001 environmental engineering course that I teach, I've been using the example of the Flint, Michigan water crisis. It was just a absolute nightmare. As an environmental engineer, I'm like, oh my gosh, how can this happen? But it did. Flint, Michigan, birthplace of General Motors, was a huge, oh, not huge city. It was a big city, had about 200,000 residents. But then the oil crisis hit and the population dropped and the city was in debt. And so that's a problem. And people at the state level are like, what can we do to maybe save some money? Oh, we know, we will change the raw water supply for the city of Flint, Michigan. We'll go with a different water supply that's closer to the city. So we don't have to pay the money to transport that water from the source to the city. The problem is that when they did that, there's a lot of chemistry involved, a lot of old pipes and stuff. And when they changed that raw water supply, big problems happened. Lead basically leached into the water supply. Residents started seeing dark, disgusting, smelly water. They were getting rashes, their hair was falling out. And there were just very high levels of lead in the water. 9,000 children were impacted by this. Little babies, their systems just cannot handle lead exposure. And eventually it was an independent task force that verified the contamination levels were very, very high, and it blamed the government workers at all different levels. Eventually 15 people were facing criminal charges because they either tampered with data or they tampered with the testing that was taken, meaning they told people, oh, clear your pipes out, and then they would come test the water. Can't do that. But the bottom line too is that, the people that made the decisions were not scientists, they were not engineers, and they just made a decision based on saving money. This ended up, remember, they were 25 million in debt. This ended up costing them $600 million. So yeah, big problem there. And just an example, like I said, of bad decisions being made and unethical activity for sure. But again, discussing issues like this is what happens in all of these 3,000 and 4,000 level courses as you move up. So it's really a cool thing here at UCF that you are constantly reminded of the responsibilities that engineers have.
And I'm back at Farrell Commons again, and I am in a spot on campus that's honestly pretty poignant for me. In this exact location, I had run out from the student government buildings to watch a shuttle launch, and I was very excited. It was a beautiful January day, cool, not a cloud in the sky. And I turned eastward and looked up to watch the exciting launch, only to see that cloud trail. And I knew right away that something had gone terribly wrong. And I rushed back inside and heard about the Challenger tragedy. And I bring it up today because, sadly, that tragedy provides the perfect example of professional and engineering ethics. The bottom line in this whole scenario is that someone predicted what was going to happen, and he tried desperately to tell his bosses, and they just didn't listen. So that's kind of the theme of what we're going to talk about next.
So what resulted from that? Basically, the Rogers Commission said that NASA had major failures in communications between engineers and managers. There were conflicts between the engineering data and the manager's judgments. And then the overall NASA structure at that time did not let the conversations that were happening at the lower level, the very important engineering conversations, did not get up to the top. And that has been fixed, which is good. But that was the big problem there, is that these issues just kind of bypassed some key managers, and the wrong decisions were made, obviously. So tragedies have resulted many, many times in engineering due to errors, lack of oversight, poor decisions made by engineers, but also by the leaders and the managers as well. And just to look at a couple real quickly here, the Hyatt Regency Hotel, they had a walkway over an atrium, kind of like what we do here in engineering, our engineering atrium, but ours is a supported structure. This was hung by rods, and then these rods apparently were not strong enough by code to handle that weight for a long period of time. But rather than catching that error, they kind of accidentally doubled down on incorrect and added a second walkway that was connected to the first walkway that can't handle its own weight either. But the bottom line is that there was a lot of mistakes made, things that were not caught during design. 114 people died when both of these walkways came down during a party that was being held at the hotel. And it was, again, poor reviews, very poor reviews, and also poor construction oversight as well. It wasn't caught during the construction as well. The FIU bridge, that was alluded to earlier by Dr. Chopra. Here's some more details about it. Lot of problems here. The engineers, they had a faulty design. It was a pre-stressed structure that was not designed properly. The site engineers saw visible cracks in this pre-stressed structure and did nothing about it. So huge flag there. Managers let traffic go underneath this new bridge. I don't get that one at all. And then finally, the state of Florida allowed employees at FIU to supervise the construction of this bridge. I guess they thought, well, since it's a preformed, it just gets dropped there, we're good. No, the FDOT should have been reviewing it. The true professionals should have been there. 5 motorists were killed and 1 construction worker died on site. So very, very sad tragedy, and sadly just a plethora of mistakes that were made there. Okay, so I know a lot of things you've seen: civil, environmental, and construction engineering, real heavy in that, right? But no, I don't want to exclude people. So here's some mechanicals, right? Here's, if you're a mechanical engineer, you might be working for General Motors. But in this case, what happened with this tragedy, the design engineer knew that the switch for the ignition key did not meet GM specifications. And however, he just kind of said, oh, okay, well, that shouldn't be a problem. What? No, no, no. When you are given specifications and you are asked to see if a piece of equipment or a product or a tool meets those specifications, they have to meet the specifications. It's not your job to say, oh, I think it'll be okay. So see, this is where people just make assumptions and they're not doing their engineering job. They're not following through properly. What happened was because the spring didn't have the proper tension, if you hit a bump while you were driving a car, it would literally have the key turn your car off. And 124 people died, and there was lots of money paid out, and 30 million cars were recalled. It was a very, very big deal. It did result in something that was good, in that GM started their Speak Up for Safety campaign. And that's very important. I keep talking about having courage to speak up. Wrapping up here, the expectations of an engineer: technical competency. It starts here at UCF. It starts with you being a good student. Don't cheat, don't plagiarize, have high academic integrity. Professionalism. Take your job seriously, understand the responsibilities, treat each other well, and then finally speak up. Having that courage to speak up, that is something that an engineer must do. All right, now, in closing, I just want to say that, look, you now know, and I'm sure you knew before, but we really drilled it in today: responsibilities. There's a lot of them that an engineer will have, but I don't want you to forget what I call the awe of being an engineer. the awe, like, wow, look at this project, look at this building, look at what this tool can do, look at this, circuit that I designed that created this machine that can now help people. I mean, there are so many different things that you all will be doing, that's in your future. And I encourage you to do that. I want you to just remember the awe of engineering, and it is an awesome career.
Hi guys, welcome to Go for Launch with the GTAs. Today we're doing a really short session. We're at Panera studying. We're going to take you to some of our fun studying spots over the next few weeks, but this is our first one. Ella's going to run through your announcements while I chug this, and we're going to see who finishes first. All right, are you ready?
Ready?
All right.
All right, October 3rd, first of all, you guys are going to have the freshman RSO fair that's going to be in the Engineering 2 atrium from 1 to 4. I will be there representing the class. If you have any questions for me or about the class, I can get those situated for you. Also, don't forget, next Wednesday, October 1st, is the career fair. It's going to be at the Addition Arena. Make sure you guys bring your resumes and you're dressed nice and snazzy for that. Also, next week, we are officially going over the robot project. You're going to get all the rules, all the guidelines that you need, and you're going to see the robots in person as well as the scoring zone. Then, as our last reminders, don't forget to do your Excel due Sunday at 11:59. And now is your attendance time.
Yes, go take your attendance quiz.
I win.